Hello, everybody. Welcome back to the Power Driven Podcast. We got a good guest today. We've had a few guests recently. It's been pretty fun. Today we have John Schroeder from Black Tie Race Fab. He's here helping me build the Godfather race truck, and he's helping me more like I'm watching him. But I will get involved later when it's in my area of expertise. So John also is a big fan of all things diesel, big fun stuff. And since he's here, we'd like to get his take on things as well. So today the topic is how to make 1,000 horsepower 12 valve. We've done the 500, 850. This is more like, guys get to this level with their 12 valves and it turns into just a beast, like a real crappy truck, not from the street, smoky. A lot of guys putting 13 mil pumps in there. So terrible throttle, it's like jerky throttle. Just a lot of nasty stuff happens when you go big pumps. And you don't have to do that anymore for 1,000 horsepower.
So we're not talking 12, 1,500 horsepower. We're talking 1,000 rear wheel horsepower truck, like the Junker has been for years.
And it's fun to hit 4 digits, right? I mean, honestly, it's like that's kind of like one of like the bridges you cross. You get 500, 750 is good, 800, but 1,000 like near 4 digits. You start with torque. Oh, I got 1,000 foot-pounds of torque, which is a legit thing. It's big to the wheels. 1,000 horsepower is another thing entirely. So it is like a bridge people want to cross. I wanted to cross it at one point in my life. Meyer still hasn't crossed it in 12 valve.
Correct. So
it's been
true.
Close.
I was actually thinking about that. The only 12 valve I've ever really built makes like 700 horse. Everything else is like for you guys.
Yeah.
Like, cool.
He's been involved in many big power builds. Don't get me wrong. But I do want to talk about, 1,000 horsepower on the street, 12 valve. 12 valve is a very inexpensive platform to get into compared to like a lot of stuff. Well, not if it's clean, it's not inexpensive. We'll say that.
Not anymore.
But
the truck's not clean, but the performance parts are cheaper.
Yes.
For sure. Yeah.
Yeah, so let's talk about it. Like Meyer is thinking about this specifically because you had a guy call you. Like, what was this guy experiencing? What was his problems?
I mean, I've actually been on multiple different people, but either they're shooting for 1,000 and trying to get an idea of what parts they need and how crazy to go, or they've had a goal for 1,000 and they're struggling to hit it and they've got all the parts. Like, why isn't this working? And that I always I want to circle back to, I feel like a lot of people think that 1,000 horsepower is a lot, and it is a lot, but they start just throwing the book at it with the parts, 13 mil pump, big turbos, all this stuff. And now you've got this super lazy fuel injection system that you have to push the crap out of it to get to the power level you want, to that 1,000 horsepower level. It almost feels like being more conservative, keeping your injectors conservative, your pump conservative, and just like having a better game plan and better turbo set to get there, it just wins.
I really agree with that. I think people do go overboard. I mean, I did this in the past. When Will and I first started Power Driven Diesel years ago, I had the Frankenstein truck, which is a triple turbo, dual water air intercooler, and it made 1,350 horsepower. But to enjoy it, you needed a really long stretch of road.
Oh yeah.
Like there's no like just a little hot rod around town or quick stoplight, something fun. Like the shorties of totally the opposite. Shorties is fun everywhere. That truck was super fun on a long stretch of road.
Yeah.
And one difference is because you kind of overbuilt that with huge turbos and everything, it pulled hard to 5,000 RPM. Yeah. There's no layover. The Junker right now, it has this smaller turbo setup on it than that. It lights early. It makes a lot of power, a lot of torque, but it also, I don't think it's going to carry at 5,000 anywhere near a big triple turbo setup. But at the same time, for a street truck, you don't need it to carry to 5,000. I think where a lot of this oversized problem came from is a lot of the technology in 12 valves was developed sled pulling. And a lot of sled pulling trucks are set up to make peak power at high RPM, come off the line, and they're not really worried about spool up. They're just trying to maintain power and reliability at higher RPM. And so because of that, they're oversizing the fuel system. They're oversizing the turbos. And technology advances too. I mean, stuff that we did 10 years ago, I would never do today.
No. What about you, John? You're a big 12 valve guy through and through.
Yeah. I mean, when I wanted to make, like the first time I made 1,000 horsepower with a mechanical truck was, I don't know, like 15 years ago. And obviously, like you said, technology is way different than it was then. But the first time I did it, I had a 366 and a 485. And I mean, that's still, like moderately sized turbos, but I feel like you can get away with a little bit smaller turbo setup, or at least the manifold charger now than you could then. But
what was the exhaust housing on the 366?
It was the 74 turbine, and then I don't remember.
Was it an internally gated one?
No,
or was it a fixed T4?
It was a T4.
So it's probably a 91 or 10.
Yeah, I think it was a 91. But mean, it ran fine, and it had a little bit looser converter, which I feel like that's something that people have problems with is they don't want to put a loose converter in it and make it drive bad, but then they put a big turbo or a bigger turbo on it, and then they can't get on top of the charger. Like on a 12 valve, you're not going to run like a bigger 300 or anything like that with a lower than stock stall typically. I mean, at least not
enjoying it.
Yeah, not enjoy it really.
Yeah.
Where common rail stuff, you can put a decent sized charger on it and run a pretty tight converter. So I feel like when people are just doing like a quick search on it and they're looking for the recipe, they try to look into common rails, and it's not the same. It doesn't I feel like you need a looser converter in a 12 valve typically to make the same power, and also you run typically a little bit different spec'd charger. Like the common rail, you can get away with a little bit smaller turbine, where the 12 valves, in my experience, they seem like they like a little bit more turbine wheel than common rail truck to make the same power.
Meyer talks about that a lot. And why is that? You guys both come to the same conclusion, which I agree with. What is it about 12 valve technology that needs a larger turbine than like a common rail?
I think it's the way the burn happens, but
I think half the burn's happening in your manifold. So half the burn's actually making power in the engine where it's supposed to, and the other half is happening in the manifold. So you got all this exhaust energy that is trying to get out of the turbine wheel. And so you need that big turbine wheel to not only let that out, but also you need to be able to utilize it. If you just wastegate that away, now you're wasting that energy. So you need to be able to utilize it, because also the 12 valve head flows like crap. And so you need all that boost in there and all that air in there to be able to make power. And so it's like it's happening in the manifold. You have to utilize it somehow.
12 valve head flows like crap.
It flows like crap. Yep.
I feel like they flow pretty good at big lift.
And I think that even if you had a P pump 24 valve, I think the trash mechanical injection still like needs a bunch of air to make power. I mean, Todd makes 120 pounds of boost, like fuel only. You're making 110, 120 pounds of boost.
Probably.
I think right around there. And you're making 1700 horsepower.
However, I have the timing set for nitrous on that one.
I mean, back when you didn't have it set for nitrous,
yeah.
you 1700 horsepower is all you made at 110, 120 pounds boost. At 80, I'm making 18 something. Like the mechanical injection is not as efficient. Right. It's not as high pressure, whatever it is. It's not as well timed, whatever the deal is. And so
we still got to bring it back to perspective for people though. This is with essentially the same cylinder head. It's not like
it's the same
Todd's
cylinder.
12 valve.
Oh yeah.
So this is P pump 24 valve. A lot of guys probably didn't pick up that you're making
same engine, same
40
head.
more pounds of boost to make a little less power than a common rail.
And that has a flip side. First, I mean, crap pisses me off because I can only make 80 pounds. I know if I made more boost, I could make more power. And my interstage boost is like 30. He has the same charger and he's making 65 pounds interstage and he's just driving the crap out of it and he's gating.
Yep.
What the crap? I can't even get mine to drive that hard. And it's because your injection event or your burn is happening in the manifold. And so it like, even though the engine and everything, like it's a P pump 24 valve, same head, same, like so much is the same, just the injection being the mechanical versus common rail injection changes how you'd spec those turbos and how you'd wastegate and like your whole strategy.
Yeah, I agree. But I mean, even like, I don't know which one of your insults to address first, but like going back to the 2 valve versus 4 valve head thing, the 12 valve heads don't flow bad. They flow bad at low lift, where like when they
flow good on a flow bench in some situations. On a truck,
but I mean, when you get into like a big ported 2 valve head, I mean, I feel like it's kind of like that with a lot of the cylinder heads, right? Like the 2 valve to 4 valve stuff, the big lift 2 valve head.
The best head that's ever been on my flow bench is a Hamilton Warhead that we worked over.
Yeah.
2 valve. So 2 valve head is the champion so far, but I have
flow numbers.
Of peak flow numbers. But at, you could say 200 or 300 lift, which is right in the middle of the lift range of the valve, I've never had even that Hamilton Warhead. It's not flowing 250, 260 which
I'm not going to disagree. Like, yes, on a flow bench, whatever. However, when I ported the exhaust on my head, you said with the cam that was in the Godfather versus the cam that was in mine, so the actual lift of the valve, I did beat you with stock valves. But regardless, that's near nor there. Yes, like you can get a 12 valve head to flow, but it's just not. It's
big lift numbers, big cam.
Yeah.
That's not stock truck
We're
stuff.
talking exhaust side, not intake.
Yeah, intake is.
You
yeah,
couldn't get the
I could
intake to
not.
flow as much as the exhaust.
I
on
could
yours.
not. Yeah.
And the Godfather's intake tremendously outflowed the exhaust. It was like 330 CFM.
But the 4-valve head, kind of going back to the street truck thing, the 4-valve head beats it on the street because it like the valve starts to crack and it flows so much more. So even in a mechanical truck, that 4-valve head is a benefit because you're getting that air in and out of the engine faster. So the 12-valve is not only fighting the injection event, but it's also fighting an inferior low lift cylinder head.
Just inferior, just in general.
So I think we're getting a little bit off in the weeds talking about 1,000 horsepower 12
sorry.
And I think we need to start a little bit with the foundation. There's some key foundation things to make a 12-valve survive that power level, engine-wise, fuel setup-wise, that a lot of people just don't know. So I think the engine foundation is probably the first place to start. And I like to just start right with the bottom end. We just proved on the junker that factory rods can do 1,000, but you would be stupid not to put rod bolts in there while you're there. The junker does have rod bolts in it.
Yep.
But beyond that,
I feel like for the most part, if you're going to make 1,000 horsepower engine, you're probably building an engine. Even the junker probably has bigger clearances, and even
for sure.
So like, okay,
that's where I was going to go next.
You got to need clearances, and so you need to really understand what you want to do with this truck and what RPM range you want to live in. Like, yes, the junker has done it. Will it do it on a drag strip and survive the shifts?
Yeah,
probably
and
not.
if you built 20 engines the same way, would all of them survive?
Right. So I would say rod bolts minimum. I still think it would be at least some like Street Fighter type rods or some. I would, if I'm building an engine with the purpose of it making 1,000 horsepower, I'd say the 12-valve rods are right there on the edge. And if you're going to use RPM to make it, no problem. If you have the street friendly one, like the 62 Charger you have on the junker, I think you should do some kind of rod upgrade, because otherwise you'll be back in there most likely.
And then break that down a little bit more. With RPM, you can make the power with less torque.
Correct.
But for a street friendly truck, you don't want an RPM engine because it's lazy. So you want a torquey engine. Torque is what you feel. That's what you drive on. That's what pulls off the stoplight. That's what does the burnouts. That's what. And so
you shift.
So you're going to build a torquey engine that sucks down hard on the shifts and really goes. You need rods in there, 100%.
Yeah, I would advise rods for sure in that engine. Other than that, I mean, as far as like upgrades, clearances,
we should talk about that a little bit. I mean, factory pistons, they're about 4 to 5 thousandths piston to wall clearance. The junker has 10 thousandths on the tightest cylinders and 11 on the hottest cylinder, number 6. So we're talking 11 thousandths piston to wall.
Double.
Which everybody's worried about doing that because they think they're going to have like crazy blow by. And I mean, that's not really the case. As long as you have the rings set right and everything in it. I mean, you can run 10, 11 thousandths and not have crazy blow by.
Now it does wear the engine faster. The piston rocks more. The ring does more weird stuff. This is not a 1,000,000-mile motor with that kind of clearance.
This is a 1,000 horsepower engine. Yeah. Do not be thinking you're building this and going to 4 million miles. That's a bad idea.
And so you're building a pre-worn out engine as far as piston to wall clearance. In fact, I don't think I've ever seen a stock engine even that wasn't eating dirt that's bigger than, I'd say, about 8 thousandths piston wall when you tear them down with 1 billion miles on them. I've had some that were like probably 40 thousandths piston to wall, but they didn't have an air filter clearly. And there wasn't like a ring ridge. It was like a 40 over piston, like was too, like this was a standard bore, standard piston engine. And it was bigger than 40 over. I couldn't even machine a 40 over. I'm like, how the heck did this thing still run?
Yeah, the compression was terrible.
But it came in as a course, so I'm sure somebody ran it till it wouldn't start anymore. And they're like, all right.
Yeah.
So they can, but still, that engine theoretically ran at 40 over. So that was probably like 48 thousandths piston to wall. So
a little bit of blow by in that one.
Probably a little bit on that one.
Probably, for sure.
The ring gap was yes.
Yes, all of it.
And we should talk about rings really quick too.
You're going to want to open up by going bigger piston to wall, your ring gap will naturally open, but it's probably still not enough. Like,
but Cummins max spec is 26 thousandths on a 12 valve. The junker is more than that. It's like 30 plus.
Yep, 30
on that top ring. So
you need to have room for things to grow at 1,000 horsepower. It's just a fact of life. And that might become the blow by. You need some oil catch cans. The blow by's not bad on the junker. I wouldn't say it's bad at all, honestly.
It has the valve covers that
the dual valve
that
cover
catch
breathers.
that. Yeah.
It's not bad at idle. When you do a really hot rod burnout and then stop on the concrete, you need some kitty litter.
Okay.
But
That engine-
burnouts are different. That's like
Yeah.
a different breed of stuff,
Of
though. Like
pain.
they break things, and I'm not talking about like a quick burnout, like the burnouts that you guys do in that
Yeah.
stuff. Minute burnouts,
Yeah.
those break things that people don't typically break. That's not. I mean, you can sled pull, drag race, all kinds of stuff, and I would say that's like responsible horsepower use.
Yeah.
Burnouts are just destruction if you do a minute-long burnout.
Yeah, that's true. There's an engine over there, right over there, sitting in pieces.
Just massive heat.
Oh, incredible heat. But yeah, so tolerance has got to be up a big amount. So yeah, you're gonna have to go to at least in the bottom end. Like I say, you don't have to be crazy. I mean, a set of rods, some good main studs, obviously. Not even main studs, really 1,000 horsepower. You're using main bolts in the junk right now, and those have been
I
great.
mean, it's true. That engine, just to clarify for everyone, I don't think when we built it, we were really thinking it was going to hit 1,000. I don't know what I was really thinking. I think we were thinking like 600, 700, 800 horse. The purpose of the engine was for it to be in the junker so we could do a bunch of like, stockish turbo testing, and that way employees could go and just drag race it at the strip and it could be reliable and safe and people would just go rounds.
But we wanted like OEM pistons so that we could do turbo testing at that lower, you could say 500 to 900 horsepower level, maybe 850 horsepower level. That's what it was built for, because I had broken the block. It was at 1,500. Wheel was the best dyno, broken the block, parked it in the back pasture, and then we all got this bright idea. Hey, let's bring this back because it's two-wheel drive. It's a great test rig. It's easy to work on because
we don't care about it.
It's junky. So if an employee crashes it in the wall, no loss, as long as the employee's safe, we don't care. And so that's what that engine was built for. I didn't even build the engine in that. I wasn't involved at all.
It was built in my garage.
Nice.
Not even that power driven.
In fact, an old employee, wire wheel Nick, helped. Thanks, Nick. Great engine.
He did great. Yeah. It was his first engine. Like I just kind of showed him. I was like, okay, this is how you do this one. And he's like, okay. And he just did the rest of them. And he's like, okay, what next? And just did the whole way. And so he basically built that engine. And yeah, it's been great. It's an absolute unit. So we did, that being said, circle back. It has main bolts in it. At 1,000 horse, I'd be putting main studs in it. I guarantee you, just with what we know, like those caps are fretted. They haven't failed, but they're fretted, and it probably won't be the failure point of that engine, but the bearings are not going to look good when we take it apart.
Is that a 12 mil main or a 14 mil main one?
Socket head cap bolt. Socket heads.
So we
14s.
upgraded the bolt from a So
Yeah.
factory's a 10.9, right? I think factory's a 10.9 bolt.
I don't even know if that's true. I mean, they're the skinnier shank. I think they're the same as they're a 12.9, so they're the same as the head stud.
But
And
they neck down.
yeah, we just
Weird.
didn't have them, so like I was going, buy some bolts, see what happens. And so the mains aren't super special. They're just 14. What's really special in that thing is the 14 mil head bolts, because that block was originally going to be a Will Terry build block. And then you found a blem in the cylinder wall. We put not even a flange sleeve in it. We put a repair sleeve in it.
Nice.
And Will's like, I'm not running this anymore. But it had all the piston in the wall. It had all the oil pump mods. It was 14 mil top and bottom. And I was like, well, you can't sell this. Like, what are we going to do with it? It's basically a junk block. And I was like, Inferno C. Like, we're gonna just build it and see what happens. And so yeah, we put 14 mil bolts in the top of it, and it's been solid.
But to clarify for people, the 12 valves are the only ones that you could get with 14 millimeter mains.
Yep.
And that's the single turbo drain blocks that have 14 mil mains. And the top.
Fun fact though is power driven. Now we have our own 12 valve blocks.
Nice.
They're storm blocks, and we have 14 mil mains.
Nice.
Kind of had it because we want the both best. We want the twin oil drains, and I want 14 mil mains.
Yeah.
So we kind of made that standard.
So if you're
Nice.
looking for a new 12-out block, the other one's worn out, or one that's all machined ready to go, the blocks that we have in stock and sell, they have 14 mil mains, and we already put socket cap bolts in there. So technically you could copy the junker build just by buying a block. It's right there. We can make the piston wall bigger, for you in our various stages we have there.
And not have to weld a bung in the oil pan for compounds.
Right.
Mm-hmm.
Which sucks.
It does. It's terrible.
Yeah.
You get
So-
a nice new oil pan or something. You got to, yeah.
But moving up to the head on 1,000 horse 12 valve, if you have perfect turbo systems, you can make 1,000 horsepower with a stock head, but it's so much easier with a ported head. 12 valves make a lot of boost. Factory intercoolers blow up regularly once you go past 75 pounds of boost. If the junker did not have a ported head on it right now and the wastegating, I'll bet it'd be 150 pounds of boost. There's no factory cooler. You wouldn't be able to keep boots on it. You wouldn't have zero fun. Like purely from reducing the boost, the ported head is worth it for a street truck.
Keeping
besides the power gain and all that, but
keeping boots and intercoolers alive at that 60, 80 pounds, it's not hard. You get to 100, like, yeah, you got to make sure your clamps are tight. You got good boots in there. 150, that's a lot of pressure. Like, it's ridiculous. Keeping your boost away from that range just keeps everything else more reliable.
I think even 100's like pushing it. Like Ruby has blown. I mean, I got more dents in my hood from about 105 pounds of boost and that thing. And I've got double clamps. I even had a bar that came out of on the burnout. And I got super hot. I'll give it that. But
100 the paint off the turbos. It was hot.
Melted the
air filter.
Yeah, melted
Melted
the air
everything.
filter off.
But
yeah,
I popped the hood and the air filter's like sagging down. And I was like, what did you do to this thing?
I don't know. And it's like, oh my gosh, it melted. I've never seen that. That's a record. So anyway.
But so you definitely are going to want a ported head. At a minimum, you need, O-rings are not enough at 1,000 to be reliable. You really should have a fire ring setup. That's what the junker has, is fire rings with 14 mil socket cap bolts, and it's holding. That's an experiment, but so far it's been very successful. But most guys, you're going to go right to a custom age stud, like an OptiTorque, stainless custom age, or an ARP 625. You're going to need the top end secure there. On the head itself, the junker has our stage 2 hot street head. You're going to want.
So fun fact, this is my favorite thing on that head. So when we developed the first stage 2 head, obviously, you port it, you try something, you flow it, you're like, okay, not quite, didn't miss the mark. And you just go down the cylinders, making different changes and tweaks and everything. So every cylinder is ultimately different. It's that head.
Oh no.
We're like, well, what are you gonna do with it? Perfect. Slap it on the junker.
Can't waste a head. Valve
great.
springs. 60-pound valve springs are not enough for 1,000 horsepower. You're making a lot of boost, a lot of RPM. You need like our street conicals, or
that's what it
at
has.
a minimum. And then ideally, it just depends. If your goal's just 1,000, street conical is perfect for you.
And something else, this goes for any build at all. Like a 60-pound valve spring is an awesome valve spring. It gives you the RPM capability without a bunch of over the nose pressure. And so you're not going to wear out your cam. It's a great 1,000,000-mile valve spring to put on your tow truck, whatever it is, it'll work. It doesn't have a lot of valve travel. And so anytime you put a bigger cam in your engine and you got 60-pound valve springs, you want to double check to make sure you have enough spring and you're not going into coil bind. And so with the cam that's in the junker, it probably wouldn't even work with a 60-pound valve
coil
spring.
bind them.
But that's also another thing. You kind of went to the head, but going back to a cam, don't go crazy with the cam. Like a lot of people go to like a stage 5 Colt or what is it?
188, 220 or
188, 220 I think is mild, but like a 207, 220, like stop. Like you're making 1,000 horse. I'd probably, it'd be either a 178, 208 or a Colt stage 3, Colt stage 4, something in that ballpark. Just fine. You're just trying to get the valve to open a little bit more, just to utilize that head flow, and you're good.
And part of why you're going to want the aftermarket cam is to make 1,000, you're working that P pump hard. It has a lot of horsepower. It's drawing off of the cam. Those are helical gears. There's a lot of twists going on the nose of the cam. Factory cams are not as strong as these aftermarket. The aftermarket has made the cam fatter, especially Colt. They worked a lot on the metallurgy when they were designing those cams years ago. And so the metallurgy is better than a factory cam, and it's fatter on the beam there. We've never even broken a Colt cast cam. We've broken steel cams. I'm
running a Colt cast cam in the Cummins car right now with a 14 mil. I think the reason I get away with it is I have straight cut gears. But I have not ever broken a Colt cast cam, but I've never ran a Colt cast cam with a real big pump either.
With helical gears.
On a helical gear.
But you've broken a couple cams on your truck.
I've broken steel cams.
Man, I'm trying to think. I don't think I ever broke a cam until it was making like big power. But I know that you can.
You always had a 13 mil or bigger pump when you broke them. Did you ever break one on a 12 mil?
No, but my truck made 1,500-ish horsepower on fuel, 1,800 on nitrous with a 12 mil. And I just like 12 mils, how they perform until you get crazy. I feel like the general rule of thumb where people would talk about it is like, 1,000 horsepower, you need a 13 mil pump. And
No.
I disagree with that. Obviously sled pulling is different, all that kind of stuff. It just kind of depends on what you're doing with it. But I think the old school rule of thumb of 13 mil pump for 1,000 horsepower is not good anymore. And I think people don't understand the forces that puts on everything else. I don't know the exact horsepower numbers, but I mean, it takes more power to run a 13 mil pump to spin it. It loads everything harder. So like going back to the helical gears, I mean, most people the other thing about the factory cam versus an aftermarket cam is the factory cam doesn't have the bore in the center of it. So you start getting like a higher RPM or anything, it'll walk that cam gear off, push it into the front cover. That's like I feel like the first hurdle you run into with a camshaft, and then
it's probably around 750s
Yeah.
usually when I see them start to walk regularly. So
yeah, and then you bolt that on, hold it in, then you're past that. But you start to get the big power stuff like 13, 14 mil stuff, or just high RPM stuff like that. It's trying to walk that cam gear forward, but then you're driving the pump, so it's pushing that gear in different directions, and like that's why it breaks the nose of the cam off. I think
because the cam's the bearing or the shaft that the gear's riding on, and the gear's in a bind because the way it's getting loaded.
Yeah, and I mean I've broken multiple. I think I broke a few here, and then on the dyno, and then I broke one
drag strip.
Yeah, I broke one on the drag strip too, and then straight cut gears with the same camshaft, never had an issue again. Yeah. So, but that's not a 1,000 horsepower thing. That's more than that.
Yeah, you get away with 1,000 horsepower on helicals, no problem. The simple, a good cam, 12 mil pump.
And that's another thing nice about a 12 mil pump that you lose going to a 13 mil is your timing advance.
Yeah.
Is on a 215, you're getting 6-7 degrees of timing advance. That means you can set your pump to, I mean, the junker's at 26, but I mean, you can set it to 22, 24, super drivable, super daily drivable, like run great. My old 12 valve tow truck I was towing with was at 24 degrees and it was great. And then you give it throttle and it advances. And so now you're into those 30 range. And so it makes not only is the pump, just the plungers and the whole balance of everything just more streetable, but now you're getting this timing advance so you can run it more like a more conservative timing, more streetable, and it just drives even better still. When you go to a 13 mil, you'll lose that.
Yep. Yeah, that's a huge thing. So I want to talk about like this customer and others who called. Okay, he's got a 400 kit. He's got a bunch of stuff, 13 mil pump. What's happening that people are getting stuck? Why is he stuck? Why is he not making big power?
I mean, I don't know specifically. I mean, obviously, if I knew, like, I'd tell him. But he posted his boost at over 100 pounds, and so I have to think he's driving it plenty hard. I wonder if the 13 mil or some combo in his build is just maybe he's got really conservative timing. I think he's got 22 degrees. It's just burning. He wants to keep it treatable, which is fine. But 22 degrees on a P pump or on a 12 mil, like a 215 pump, would then advance to 28 and it'd be fine. But 22 degrees, I mean, regardless, like I do think if you have a 13 mil, you should probably be thinking about running more timing than that. Like you need more, like that you have to run a big enough injector with a 13 mil to where now it's a big lazy shot. And then it's going to take longer to burn.
I mean, I think you've uncovered exactly what this guy's problem is.
Yeah.
He has a 13, so he has to have big injectors.
So that's the funny thing though, is he doesn't have big injectors. People were saying like, oh, you need bigger injectors. And I was like, they're good for the goal. Like on 215 pump, they're like a DDP stage 4. And so on a 215 pump, that'd be great combo for 1,000 horse. But on your 13 mil, theoretically, it should make 1,000 horse. But that's probably a little small for the pump itself. And so I was like, I don't know if your pump's going to survive at that, like doing that forever. But he's also got the pump turned down to 675 cc's. And I told him like, okay, 675 cc's on a 13 mil is not the same as 675 cc's on a 215. Like we've seen it. Like you put two pumps that have the same cc's, but one's a 12, one's a 13. The 13's putting less fuel in the cylinder. But with how much boost he has, there's a good amount of fuel going in the cylinder.
But it's burning
in the manifold.
Yeah.
So
that's why
is
the
that?
boost is high.
Yeah.
Because we've played with my truck a bunch, and when we go from low 20s and we bump up the timing to 30, I'll lose 10 pounds of boost and power goes up.
Yeah.
Because more of the burn is happening at that 15 degrees after top dead center. That's when your piston has the most leverage on the crank, is 15 after. If it's not really getting the big bang going until 50 degrees after top dead center, it's going to have a lot of exhaust energy left over to drive the turbos. I call it phantom boost, is what I used to call it back in the day, where you get big boost, but it's not really making making the power that you want.
You got
it's
a 2
burning
foot
exhaust.
2 foot flame coming out of the hood stack.
Mhm.
That's not good.
Inferno. See, dude, when you have a foot flame coming out of the rear exit exhaust,
Yeah.
that's when you know
That's
it's good.
That's not good.
That's good. Spools the crap out of a GT55.
I feel like, I think we talked about this before, but like with a build like that, you really got to decide going into it what you're going to do. Like, what's your goal? Because it's like, just when you're describing that build, half of that build is set up to make a lot of power, and half of it is set up to not make power.
It's a 1,500 horsepower build that he's trying to make 1,000 horsepower, which, like, off the bat, it's like, oh yeah, I'll definitely be able to get there. But he's not.
Well, it's because it's not. I mean, you have to plan that out before, and he's like, well, I need big turbos, I need big fuel, I need all this stuff, and then I don't want to run any timing because I want it to spool fast, and you're like, that's not going to work.
Yeah.
It needs the timing to make that setup work.
Yeah, exactly. And I honestly would have thought that with his smaller injector, it would be working better with all his settings. Like, I would assume it would be working better than it is, but there's some level of funk. And that's another thing that, like, when you're talking about P-pump stuff, we've seen it. We've seen it on yours. We've seen it on multiple different builds where, you know, maybe the pin time was set on the pump, but maybe something happened during the process of setting it, or something happened after, because there's nothing actually keying or locking the pin time to the pump shaft. And so if it just
It's kind of a friction fit in there.
Yep, it's just a tapered friction fit. It can shift. And so maybe he thinks his timing is 22, but maybe it's really 18, maybe it's 16, maybe it's 14. I had that with one of I was walking a customer through one of our pumps this is months ago now. He felt like it was acting weird, like it wasn't the timing that he had. And so I was like, things happen. Maybe it shifted. Like, use your spill port method, look at the spill port, see when it's getting covered up, and use that to judge your timing. Turns out, yeah, it was a couple degrees off. He compensated for it, and then the truck was able to make a good power. And so maybe that's what he is. Maybe he doesn't have 22 degrees. Maybe he has 16, 18 degrees.
And that can be like a pump build thing where your pump is not pin timed where you thought it was, but it could also be like you're describing, the timing slipping, or
the pin time slipping.
Yeah. And so if you have an adjustable pump gear, that's obviously much less likely, unless, I mean, there's some gears that it can spin a little bit, but like your guys' gear works awesome because it's not possible for that to happen.
Yeah.
So that's something that I feel like, for the price of a gear, it sucks to have to deal with slip timing and stuff like that. I would never try to make a big power truck with a factory gear. It just doesn't make sense to me. So, I mean, the timing slips one time and you're out, like, test driving it 10 miles from your house or whatever. Like, you could flat tow it back or whatever, or you're walking home. I mean, that's not worth it for the $500 or whatever the gear costs. But
yeah, adjustable gears are, I can't imagine having
I
an
know.
answer to that one,
I know.
honestly.
And if you're trying to make like small adjustments, it's so much faster and easier to dial stuff in than popping that gear, moving it, and
trying to clean the shaft.
Yeah, it does not make sense.
But I think on this particular guy's truck, if the first thing I'll try, if you don't want to spend any money, is I would try giving it more timing.
Yeah.
Does it get the power you want? If that doesn't do it, the next step I would say is either we're changing the injection pump to 12 millimeter so that we can get it to add more advance and have a different fuel curve, or we're changing the atmosphere charger and getting more air in the engine. And because I very rarely have we seen 1,000 plus on a 400 charger on a 12 valve on our dyno and compounds. It's just tough to get there.
Yeah. I mean, also it didn't say, well, I mean, you didn't say, I'm sure maybe his post said, but like the lift pump, I've seen people pick up a lot of power with a lift pump, where the stuff that works on a common rail, again, does not always what works on a 12 valve. And so people are like, oh yeah, I got my whatever 150 pump. And you're like, that's not going to cut it.
No. Yeah.
So
I don't remember that.
I did see a truck one time, and it was kind of one of those builds that the guy just like keeps making more power, and eventually kind of outgrows some of his stuff. And he was like stuck around 900 horsepower. He couldn't make the number that he wanted to make. He's like, I've tried everything. It's like, well, okay, well, what lift pump are you running? What's your fuel pressure? And he's like, oh, I don't, the gauge stopped working or whatever. And I'm like, that's very important information to have. But, so he's like, oh yeah, it's an old pump that I had for a few years, but it's always been good. It's a 150. was like, that's not gonna do it. And I was like, what are your plans for the truck going down the road? So you can kind of pick what lift pump you want to do, whatever. Long story short, he ended up putting a Waterman on it because he's like, I want to make 1500 someday. So
that's a mechanical
driven
gear
off the gear
case. Yeah.
Yeah. It picked up almost 200 horsepower
Mm.
because
just a lift pump.
it was sucking it down to nothing.
Mhm.
And so I think people see the gallon per hour and like on a lot of pumps and they don't understand, which it's not their fault. It's just the way that it's written. But a lot of times that those numbers are not at pressure.
Yeah.
So they
I
think
don't
that
know
they
any
have
to
enough.
advertise that pressure. That's at 0
Yeah,
PSI.
Free flow, yeah.
Yeah.
Free
so,
flow.
So that's not where you want to make it. Like where a common rail, you're making it at low pressure so they can move a lot of volume at low pressure. Where you're trying to run 60, 70, 80 PSI, they do not flow those numbers, even close to those numbers at pressure like that.
Mhm.
So that could be an issue too. But again, I don't know what that guy was running.
I
But
don't
I think
remember.
that's a part of any 1,000 horsepower 12 valve foundation. You need a good lift pump.
Yeah.
And I mean, the Junker has one of our mechanical Predator lift pumps on it. I have one on my race truck. It's very capable. The only electric one I've seen that really works well in 12 valve is that boost referenced AirDog 220, the 5G. That's what we put on Weston Champlin's car. I'm building a Dart. That's what I'm going to put in there is a little electric one in the trunk just because it's easier. I don't have any room on the front of the crank for Predator on my Dart. I don't even have room for a radiator. So,
Yeah.
you know.
He was making, I think he was making 12. I mean, he was injecting everything a 215 pump could inject, and it was maintaining 65 pounds of pressure. So,
But
seemed
part of what
adequate.
people don't understand on a 12 valve is that fuel, every time it fires a cylinder, it goes and then it opens the spill port that refills. But when it opens the spill port, it has full injection pressure in there. So it's spraying thousands of PSI pressure into the pump case cavity. That aerates and cavitates all the fuel in there. And so when it goes to refill, it's just aerated all that fuel. Well, if the cylinder before it just fired, it's trying to fill up with that aerated fuel from all the other 6 cylinders firing, and it's terrible. You need volume flow through the pump. And that's why I believe you're picking up the power is you're getting that cavitated fuel out if you have enough lift pump to kind of flush through there. So that's kind of like you could say a pro tuning secret on a big power 12 valve. You need volume, not just pressure running through the pump to clear out what's there. What we kind of get away with on the air dogs is we kind of let it flow through. And then when the boost comes up, that regulator clamps down a little, and it's not as good as a mechanical pump, but it's good enough. You're not giving up
that 1,000 horsepower market.
it's 1,000. It's totally fine. And then you're not making big pressure all the time and wearing the pump out. And
The Aeromotives, some of the bigger Aeromotive pumps, they do that. Well, it's not, I mean, I'm sure you could boost reference the regulators, but the big Aeromotive pumps flow like that too on some of them, like the bigger brushless pumps and stuff. You can get them to work. But yeah, it just kind of gets into a point that you're spending a bunch of money that maybe would have been better spent somewhere else.
I mean, there's a Fuel Lab pump that's like $2,000.
Yeah.
Electric pump. It's like,
I'd go Waterman before that.
Yeah.
I did a Waterman on my truck when it was like 800 horsepower. I mean, this was 20 years ago, but still, or 15 years ago, but still, I mean, it made a huge difference. And that's when people were saying you couldn't make 1,000 horsepower with a 12 mil pump. And you did that. I did that, like way over that. But
back when you first posted that, when I saw in the forums, I'm like, no way, this guy's full of crap. That's what I thought as a forum where I'm just like, huh, that seems ridiculous, But knowing what I know now, absolutely, you made that power. And I think the key to that was the Waterman, the good 215 pump, the good turbo. I mean, there was a lot, but the main difference between you and everybody else is you had enough. You had enough turbo to make it. You weren't a sled pull guy with a single 60 millimeter turbo or 65, and you had the volume with the Waterman.
Yeah.
How much have you? So this actually came up in a forum, I think, the other day, and people are shouting you out. People are saying you made 1,800 horsepower fuel only on a 215 pump.
I did not make that on a fuel only setup.
What is your record? We have to know so I can beat it someday.
I think you did beat it.
Oh.
I think you said you made 1505, right?
1502.
I made 1491.
Dude,
So you did beat
them
me.
are rookie numbers.
But I think my truck went faster. Mine ran 960 at
Doesn't matter.
6,600 pounds, 6,800 pounds. 960.
We're talking fuel only numbers, though,
Yeah,
right?
fuel only. That was when it was a super street truck. Still street truck. So yeah,
So still weighed
1491.
6,000 pounds. Then.
66 or 6,800 pounds. It had a full interior. It had,
Jeez.
I did take my sub box out when I raced, but it
Nice.
had subs and stuff in it. It had an 850 cage with a dash back around it and everything.
So people that don't know, back in the day, there was these pop-up stereo shops all over, and you go to your local stereo shop and get a system for, you drop like $5,000 and put this like, put some kicker solar barrack subs in there, and a lot of you guys don't even know what kickers are. But anyway, back in the day, that was
Shame, man. Kickers were the
I
thing.
made mine. I made my sub box. I gave my back seat a lift kit so I could have my 212s forward facing, and I made this sub box that contoured the floor and everything.
And your buddies knew when you're coming because they could feel the rumble from the stereo before they could even hear the. I mean, this is back in the day. Now,
early 2000s.
I don't know many people that compete in audio stuff now. It's like not as popular. I don't think.
I didn't
because everybody
compete in
AirPods now. It's AirPods. And who want,
And beats and whatever. Nobody needs to rattle their brain and piss off the
One
neighbors.
thing I do want to talk about, we're kind of running low on time here, but we haven't really addressed turbo systems.
Mhm.
Like, we talked about, okay, this guy had a 400, which is not what I would do for a 1,000 horsepower street truck.
No, that I did not. So we just downloaded the junker. It has a 62-9. So it's like a 351, but it's got a more second gen friendly mounting. It's great for compounds because you can clock the compressor cover, V-band outlet on the compressor, not the 4 discharge, HX40 outlet. Like it works way better in compounds. We put that in there after Will blew up 2 chargers at the SEMA, because that
After you sabotaged me and made my turbos blow up.
Yeah, exactly.
He's on a beach in Hawaii
I
sucking down a mimosa, just like, yep, I did that.
You and I both know we saved that engine. But anyway, he had a 351 on there, and I had custom like welded a bracket to the housing so that way I could clock it. It worked. It was fine. But this -9 is just dropping, and it's great. And so that's what it's got on the manifold. And then we put an Aggressor 98, and I did not know how well this Aggressor 98 would work. In the past, we had an Aggressor 80 on there, and we were in that 960 horsepower. I think the best we did was 984, and then we did some injector testing, and we actually made less power with the injectors, and they just stayed in there. So we were at like 960.
So yes, you can make less power with bigger injectors.
Yeah.
We tested and proved that.
Oh, we've done it so many times. And I think that's a big problem that people do is they put these big old injectors in there and then wonder why it's lazy. Like and bigger injector reduces pressure, and that pressure really helps the burn. Anyway, put it on the dyno, and it's ridiculous. It's so much fun. Like it'll make boost at 1,500 RPM. It's super thrill at 2,000. Like I'm getting up into the window at 15, 20 pounds of boost, no problem. I punch it at 20, what was it? I think I was punching it at 2,000, 2,200, something like that. And within 2 seconds, it was at over 1,000 horsepower. Like ridiculously fun to drive.
Very, very steep rise in that horsepower graph.
Like so much fun to drive.
What did
like
it
on
make
the
peak?
1177.
So you met your goal
We did do the 1,000 horsepower.
Easily, yeah, like right off the bat. I'm trying too hard.
with just the big turbo change is the main thing.
Yep. That was the only change really.
So 200 horsepower going from
Yeah.
a 96 turbine to 111. That's what it is, right?
Yep.
Yeah.
255.
Yeah. And so
The compressor obviously went from an 80 to a
Yeah.
98.
Yeah.
But
boost went from like 70 to 102. And it carried decent too.
Yeah.
Like
Top
would
end's
not
way
much,
better.
much
it would
past
make
4.
more boost, but we did add an external wastegate and we opened that a little bit. If we closed the external gate, I think it made 116 pounds and we let it just do what it wanted, but it actually didn't gain power really.
We
It
made
just-
106. So we made like 106, 7 pounds with the internal gate going wide open and the external gate closed. And then the line blew off the internal gate and we had the external gate doing its thing. And that made like 116 pounds. So it would have done more if we had
if you
closed
closed
every
everything
gate.
down.
But I don't think that it would
No.
survive that very long at all.
Where do you think that, because obviously like that's a big turbine drop in. So, I mean, you think that a lot of the power gains, like you're looking for that number. So you need to run a big turbine drop in charger and then just do the big turbo to set your max power, like the 80 or in that like 800, 900 range. And then you put a GT55 style charger on
Yeah,
it
if
for
someone
the
told us
1,000
they
plus.
wanted 950 all the way down to, let's say, like 750, I'd say that 480 is a great atmosphere charger.
Yeah.
If they want more than 950 on a 12 valve, my opinion, you need to go right into that Aggressor 98.
And that's what's awesome about it is like, could you make 1,000 horsepower on a 480 in that compound setup? Sure, we didn't do it, but like we also weren't crazy with timing. We didn't have to go in and just really max everything out to get to our goal. Now we can, we could drop the timing. We could do all these things because you have so much extra air. Now, if this was like a truck you wanted to tow with, I think it would tow fine just because of that small manifold charger. But if this was your dedicated tow truck, Aggressor 98 is probably not the play. You don't need to be making that power, and you don't like that turbo is not going to do a lot to help you at 2,000 RPM where you're towing at.
Yeah.
I mean, it'll help you, just not as much as a 480 would.
And the fact
I
of the
still
matter,
think it would tow way better with that compound setup than that 62 as a single. Like not even close.
I don't know. I'm actually genuinely curious.
Well, that means
We'll find out.
Yeah.
we need to put a hitch back on the junker, you're saying, so we can tow with it and prove it? Sounds like a plan.
Yep, that's exactly what I'm saying.
And a sway bar, and what else do we need?
I've never
A
seen
lot.
compounds not tow better than a single charger in any application.
Yeah.
They beat the single
Well, I'm
charger
saying-
everywhere.
I've
Have
never
you ever
ever
seen
seen it
Have
not
you run
tow
a,
better.
have you run a 62 98 compounds though? I'm saying is at 2,000
Yep.
RPM.
I actually have done 62 106 compounds.
Actually,
On
you
a 12
had
valve.
you did 67.
Mm-mm. This is before you were born, man.
Okay, never mind.
He ran a GT 35. You know, we're talking HX35 class turbo with a 106 in compounds, and he towed with it. And Todd, EGT would go down when you rolled in the throttle.
Always,
Yes.
always.
Compounds-
Even at 2,000 RPM,
Yes. The single
That was a
charger.
354 truck.
So 2000, that would be at the speed limit.
you've never towed
Absolutely.
below 80. Like
Yeah, you got a good point there.
I don't-
single charger-
I don't know.
I do know. There's no
Go.
situation where the single turbo tows better than compounds.
You have two turbines extracting energy out of the exhaust. It has to work better. Even at 2000, in your mind, it's not going. 300 horsepower at 2000 RPM, that GT55 is making great boost. It's working.
Yeah.
Making 10 pounds probably. 5 pounds, 10 pounds.
At 300 horsepower?
Yeah.
GT55 making no.
At
Those
2000
numbers are
RPM?
wrong, but like I get what you're saying.
How much power does a semi use, a 15 liter, when it's making 300 horsepower? That would make
so
boost
at,
on a
at
GT55.
2,400
People
RPM.
tow with those all the time.
So
Yeah,
what
475 horse
on the
semis
junker-
with compounds.
When I punched it and I said like within 2 seconds it was 1,000 horse, that or whatever the number was, I punched it at like 180 horsepower, which I know is less than 300, at 2,400 RPM, and the GT55 is making like 1.6. Sounds right. So I don't think another 100 horsepower would somehow get it to 10. Doesn't matter. I would be curious.
I will say this. If you had that 160 horsepower still and it was loaded like a trailer, it would be different than being that speed. You're just making 160, but you're still accelerating through a window. Whatever it is on the street and you have a trailer, things are just different.
Yeah.
I would be curious. I mean, I know that like that charger as a single is very capable and competent. So how much would it help? That's the
And then
question.
one final thought, just while you're thinking about that. That little turbo sucking through a filter is sucking against a vacuum slightly.
Mhm.
A GT55, even if it's just idling, spinning, is probably making enough air, even at idle, that it no longer has a vacuum. It's got just that slight bit of positive pressure. So even if it's not spooled hard and going hard, and let's say it's making 1 pound of boost, 1 pound of boost is tremendously better than
its
a
air
negative
filters,
half PSI through a filter.
Which
Yeah.
I agree, but
That's why they work
I also
better.
know that like a turbo at 1 pound of boost is not very efficient, and so you're using a lot of turbine energy to create that 1 pound of boost. Does it cancel out? I don't know, and I'd be curious. I don't know, but like talking about
I think we need a test now.
I
for
I
sure,
do.
100%.
There's another thing I want to hit hard again. We've glanced on it a few times, but oversizing your fuel system, your injectors. I think when we started playing the power jets a couple years ago, we
Mhm.
really learned a lot about like, okay, we've been doing this wrong. Like 10
Mhm.
years ago, I would give you different recommendations than I would right now.
yeah.
for
I think we
injectors.
learned this. Like I think the first lesson that we had was with that triple turbo giveaway truck.
Oh yeah.
We had some 5x, I think we did like 5x20s or something
Something big,
stupid, and we were trying to make a power number, and we were just like stuck there, and we were trying to figure it out, and so we put smaller injectors in it. Like this was before power jets,
yeah.
and we picked up power.
Yeah.
We're like, holy crap! Okay, wow, we've been on the wrong. Like that was out of left field. We just decided to put smaller injectors in there.
I think this goes back to like your original customer and Will's thought about sled pulling is the reason 12 valves are so great is because you can just put stupid amounts of fuel through them. Like you just get it in there. It has like no limit basically. I mean, it feels like, and so that's always been the thing, more fuel, more fuel, more fuel. But we've really learned like, that's not the answer.
Mm-hmm.
in a non all out, type build.
Yeah. When you're not class limited on the air setup, you can put so much air into it that it kind of fixes some of that stuff. Like, I mean, when you made the 1500, your truck had what some people would consider like a smallish injector for 1500 horsepower. They were like 518s.
518s, yeah.
My truck had 7x13s in it. Like when it made 1500 horsepower, again, that's a lot of people would say like a not desirable injector or not big enough to make those numbers. But it's just, you can do so much more with better air.
Mm-hmm.
I really feel you need to match your injector to your pump.
Yeah.
I think people don't realize that. Like, I see a big injector. If your injector is too big for your pump, it's lazy. If your injector is too small for your pump, it's hard on your pump. You said this a lot. Like on a P pump truck, your parts are your tune.
Yeah.
Like you can adjust them, but you're not going to go in there and adjust a lot. Like your parts are the tune up. And so getting your injector sized appropriately for the pump you're going to use, because even if, like Meyer was talking about, like if you have a 13 mil pump at 600 cc's or a 12 millimeter pump at 600 cc's, those are two totally different animals. Because that 13 mil is going to put that 600 cc's through way faster. Much less amount of time is needed to get it through that injector. So you need a larger injector to accommodate that without hurting your pump. On the same token, if you have that injector and you put a 12 mil pump on it, now it's lazy.
Yeah.
Because it's like it wants this big, huge pulse that's not getting. Your 12 mil has less pressure pushing it through for a longer amount of time. So I would say, like, focus on getting your pump and your injectors, matched. The match set is really important if you want good manners and good power.
Yeah. Yeah. I would say you probably have more freedom with your turbo setup than with your fuel setup.
Yeah.
Your fuel setup just needs to be matched well.
Mm-hmm.
And we've had, my personal race truck, Uncle Rico, when everything is dialed perfect on the 12 valve setup, it's making a little over 1400 wheel fuel only. We just put a 6.7 in there. It has the same injector, turbo, everything is identical, same head and everything, other than it now has a 6.7 and it has a different bowl. It's a centered bowl, and I'm down 200 horsepower.
Yeah.
No differences. It's smokier now. The fuel's not
Super
burning
smoky.
as well. But this is the same fuel quantity that would go almost clean. And so, and it's still 215 pump. And what I've kind of, and it's not rocket science, but if your piston bowl and injector combo just doesn't happen to work right, it's
not going to work.
There's a 200 horsepower swing. So if I had a 1,000 horse truck, I now have an 800 horse truck purely because I put the wrong injector spray pattern with that bowl.
Yeah.
And luckily with 12 valves, the factory did a pretty good job of designing. And so if you stay within the factory stuff, you're a little better. I'm quite mismatched doing a centered bowl with a 12 valve. And I haven't dialed in the injector, but I have no doubt we're going to get back to 1,400 just by tweaking the spray pattern. I just haven't, we haven't really worked on that truck. But that's another important thing is sometimes if you have an obscure setup, who knows, maybe with this particular guy's DDP stage 4s, maybe if they had a tighter spray pattern, it might actually pick up some power, and maybe it wants a wider spray pattern.
Yeah.
Who knows what the dynamic of that 13 mil pump with, it's just kind of it's not a common combination to have that injector with a 13, and maybe the way that's delivering the fuel, it doesn't like it. Maybe it's all packing in the bowl and you've got wet fuel in there. It's not staying atomized but maybe with the 12 mil pump, that injector is awesome.
Yeah.
Which is what Lenny tested those with. I would bet you there will be a substantial power gain dropping back to 12 millimeter pump.
Well, that's why when I did mine all those years ago, the injector technology was not what it is now. And when I did that, I went from a 12 valve head to a 24 valve head because I felt like it would give me a lot better injector combination capabilities, like with the center bowl, center injector, than trying to get a weird custom setup with the 12 valve one. But the 12 valve stuff works good. And especially with the technology they have now to be able to hone in that nozzle on the right setup, then there's a lot more freedom. But I don't know. 20 years ago, if you would have tried to do that, was there any injector company that would be like, oh yeah, we'll build you an injector for that centered bowl?
Yeah. Not many guys that could tweak the pattern.
But to kind of wrap this up, this has been fun to talk about, but we're actually going to show you how to do this. Cause right now we have Vindy. Vindy's our little 12 valve test pig that we do stuff on. And the last run, that thing turned into El Diablo and made 666 horsepower. And so El Diablo.
Is that the new name? It's now El Diablo?
El Diablo is going to come back strong.
Oh my gosh.
So anyway, El Diablo is going to be our 1,000 horsepower street truck, which is going to be, very smoke friendly. It will have better smoke control than a reasonably tuned common rail, like an average tuned common rail, like a well-tuned common rail, no problem. But I mean, at least in Cedar City, I drive around all the time. I'm just seeing common rails just rolling coal left and right. Are you not seeing the same
No,
thing?
I was just looking at Meyer because
Meyer's
he's
questioning.
biting his tongue right
He's
now.
like,
He's
he knows
like, I
it's
could
true.
beat you.
He knows. I'm not saying one of.
We're not saying
A
one
PD
that
tune truck.
the tuner lives at high altitude and spends hours tweaking the tune. We're talking the average box tune that a guy buys mail order catalog
This
from
will
a
be
low
cleaner than that
altitude.
common
Maybe
rail
it came
truck.
out of
Oh, yeah.
Louisiana, and now the guy's in Cedar City, Utah, and he's like, yeah, he just thinks it's normal to have
A bunch of smoke every
everywhere.
time you come leave a stop sign.
I mean,
With
I
a
drove
common rail.
I drove that truck when it was 550, 600 horsepower. Is that when I drove it?
Yeah.
And that thing ripped for a clean. Like I was shocked at how clean it ran with 550, 600 horsepower 12 valve. It was wild. So yeah, I mean, it'd be cool to see that at 1,000 horsepower.
Yeah, it's gonna be fun. That truck just never disappoints. And like I say, I think our next step is a ported head, and then maybe some compounds and stuff like that. We got to get some O-rings in there or firings or something first. But it is a fun truck, and it will be clean, street friendly, 1,000 horsepower.
But we're not going in the bottom end. We're not going stroker right away in it. We're just gonna do top
I think
end.
we can do 1,000 before we go stroker, just to show it can be done, which we know it can be done. That's what the junker is. It's not a stroker.
Yeah.
And then they'll stroke it and make even better. So yeah, so Vindy's gonna be fun. If you're interested in like making, 1,000-ish horsepower street friendly type build, make sure you follow the channel because we're gonna do some builds on our 12 valve truck. That's gonna be exactly that. So
Will you put a stroker in it after?
I think so. Strokers are awesome because I like to see before and after, like the torque and
That's
stuff.
what I wanted. Yeah, that's what I was gonna say because it would be cool to see because everybody thinks you need cubic inches. You need cubic inches like in the gas world. I mean, that's kind of how it is. But I've seen some stuff where just curious, like with the same size turbo setup, if the 5.9 or the 6.7, I know the 6.7 always drives better, or the stroker, it comes on harder, it makes more torque earlier, it drives better. But peak power, I mean,
That's mostly your turbos.
yeah. So if you're running the same turbo setup, like it's not going to make more peak power, so it's gonna be more fun to drive.
Should be torqueier, turbos should spool quicker.
Yeah.
All that good stuff. Well, the one benefit of the stroker is you get more compression,
Okay.
and that's a real benefit.
Yeah.
And so we'll get that.
Yeah, I'd be curious. That'd be a good test.
Yeah.
I also I think we're trying to wrap it up here, but I want to touch back on something just so people aren't left hanging. We talked about a 400 compound setup, and then we talked about the junker, which is a 62-9 GT55, like Aggressor 98 style setup. Huge split. That setup daily drives super, super fun. If this was a competition vehicle, like truly competition, I feel like putting a little bit bigger manifold charger on the truck would be more reliable, drop boost, like it'd be a better race truck if it was a little bit bigger. You lose those driving manners, and that's fine. Like you're trying to go down a drag strip, it's fine. You're trying to hit it on dyno, whatever, it's fine. That setup is an amazing 1,000 horsepower street truck. I wouldn't be trying to throw that on, I wouldn't put that setup on a dedicated competition vehicle.
I mean, competition is loose term though. Like
it is.
Is that 770 or 670 or whatever? I mean, you could easily do that with your street setup and have more,
And yet turn it down.
yeah. And then you can pedal it and get back into it be a lot better. But yeah, for max power, yeah. I mean, when Will did it, when I did it, it was like a 400 on the manifold with a GT55, and yeah, it makes obviously more power, but it does not drive as well.
No, it doesn't. Like your Uncle Rico is S472 GT55. Makes like 15, same pump, like it's great.
14 on fuel.
14, yeah, 14. Same pump, it's great.
But I also spray it. I don't think the junker, although we have an external gate, maybe we could spray the junker. I don't feel like that little 62 is going to love spray. Enrico's 472 is like, give me more, Pappy.
Yeah, you're going to overpower that gate so quick with spray. Like if you did try to spray the junker, like you would not be able to put much in.
So you say 1,000 horsepower with the capability of 1,200 or so, where you want more than that, 400 GT55, right?
We're going to play with more compound setups and more turbos.
Might
but
put some S300 stuff to see. I don't know. We need to test more to really know.
John hates S300s. I'm also semi against the S300s. I'm just really curious how it acts.
Yeah.
I will say that 62, 65 we have has surprised me. Putting it in that 0.70 housing makes a big difference.
Yeah.
Most of the stuff's in a 0.80 housing.
Yeah.
Or if you get down to that 65 terminal, a smaller one, it's also in a 0.80 housing. Putting it in a 7.0 housing, like all of a sudden that turbo's fun again.
Okay.
Like it's not.
It's
It's
it
surprising.
drives really good. I mean, it's definitely a bigger charger. Like you feel, you drive it around, you watch on the dyno, whatever. You can tell it's a little bit bigger charger. But what excites me about trying it in a set of compounds is every time we ever do testing on either a 3rd gen or a 2nd gen, doesn't matter. Boost goes down, dry pressure goes way down, and we make more power
With S300.
with that S3, that 6265 7.0 housing.
versus a 67 whole set
And
turbine in
so-
like a HX35 or HE351.
Yeah.
That tells me that there's better turbine flow. It's able to better utilize the exhaust. What does that do in a compound setup? We know 12 valves love turbine flow, especially in a set of compounds. So what is it going to do?
But has the S300 ever made as much power as the big drop in? Does that? Because you can big drop in whole sets. That you're making 900 to 1,000 horsepower, right?
I
Hasn't
don't
S300
disagree.
ever done
Yeah, when
that?
you think of a drop in, you're thinking of a 900 horsepower capable charger.
On a common rail.
On a
Yeah.
common rail.
12 valve.
Yeah, but that
El Diablo's a 62.6, but I think there's some more there. I think we could do, especially the ported head.
Yeah.
I think we'll get north of 700.
I think
on
we'll
the
get to
drop-in.
700, but the junker back in the day, I think it did 721 with a 369. That's all I could make was like a barely over 700 with
Which
a
we're
Hamilton head, but
Yeah.
they're decent.
the
back then, yeah.
technology and stuff, the things we've learned since then, we could probably do better. But either
Yeah.
way, I don't know what's going to do. And that's why I want to try it.
Yeah.
Honestly, I would love for it to be terrible because then I don't need S300s anywhere in my life. But if it's great, it's going to suck. But
It has a
it's gonna be
fatter
great.
shaft, so it should handle
A little more robust.
barking and surging a little more.
And
Should
that's-
handle a little bit of nitrous better.
And that's where I would be kind of excited is if it is a more robust charger, it's got bigger thrust bearings, bigger shafts. If it works well and it still drives great and it makes more power, I could see a purpose for an S300
Yeah.
finally.
Yeah. That would be nice. That would be nice.
We can try it. But yeah, that was all my thought. I just wanted
That was
to
good
cover
thoughts.
that.
Anyway, guys, I hope you enjoyed this episode. I think we're about out of time here. 1,000 horsepower, 12 valves used to be a smoky mess, not streetable. That's no longer the issue with like AFC Live, power jets, proper tuning. Like I say, we're going to show you how to make this thing work. It's going to be fun. So follow along. And make sure you like and share and subscribe. We appreciate it. And thanks, John, for coming.
Yep.
And we'll see you next
Thanks for
time on
having me.
See you next time in the Power Driven Podcast.